In this video, we will discuss on Chapter 5, Group 1 Alkali Metal for the Part 2. In this topic, we're going to discuss about the chemical properties and some application of Group 1. On the chemical properties, we're going to look on the reaction of Group 1. The first reaction is reaction with air or oxygen. Group 1 react with oxygen and form a layer of coated metal oxide, or the element or the metal being tarnished. The reaction speed increase when downing the group, meaning that it is increased from lithium to sodium, potassium, rubidium, and cesium. To prevent the reaction took place on the element, it is usually stored in oil. So this is an example of lithium. So here is the shining part of lithium, and on top or the outer layer of lithium metal, it been coated with metal oxide. This part already been tarnished. So the speed will follow the element when downing the group. So this is an example how the element is stored. So let's say here is the limit of oil. The oxygen or air cannot penetrate into the oil, thus eliminate the potential of reaction of air with the metal. So what happened if the element or the metal reacted with oxygen? So it can oxidize into several states. So we look on the first reaction. It will become an oxide. So for the first reaction, it is suitable for lithium and sodium. This reaction need to be heated at temperature around 100 degrees C. So let's say we are using lithium in reaction with oxygen. It will become Li2O. So 2Li. 4 mole of lithium reacted with 1 mole of oxygen, and it will form 2 mole of lithium oxide. So oxide will be formed. The second interaction is to form peroxide. So for this one, the reaction need to be heated at temperature around 300 degrees C. And the element that suitable for this reaction is sodium, potassium, rubidium, and cesium. So let's say we took sodium as example. Three mole of sodium reacted with 1 mole of oxygen and forming 1 mole of sodium peroxide. The third reaction, the formation of superoxide. So this one, the condition it also need to be heated at temperature around 500 degrees C. So the metal that's suitable for this reaction is only for potassium, rubidium, and cesium. So let's say we're using potassium in reaction with oxygen at high temperature. It will become potassium superoxide. The second reaction is reaction with water. So it will react vigorously with water, with the reactivity is increasing when downing the group. So it is an exothermic reaction and produce hydrogen gas that burn at the water surface. If we look to this example, for lithium and sodium, the metal will float on top of water and give a hissing sound with the production of hydrogen. For potassium, rubidium, and cesium, it will react more vigorously and it can burn the gas directly on the surface and giving a light of fire on the top of the reaction. So this is the reaction equation. So let's say we using potassium reaction with water. So the reaction will turn into an alkaline with formation of hydrogen gas. So here we have 2 mole of potassium reacted with 2 mole of water and will produce 2 mole of KOH. This is an alkaline byproduct and hydrogen will be produced. The third reaction is reaction with acid. So similarly, it will react vigorously with acid and the reactivity is increasing when downing the group. This reaction will produce a salt and hydrogen gas. So let's say for the first example, it is reacted with HCl. So we are using lithium, for example, reacted with HCl. Okay, I will do in different color to make it clear. So we have HCl and the reaction will produce lithium chloride. Plus hydrogen gas. So here we have 2 mole of lithium, 2 mole of HCl and production of 2 mole of lithium chloride. So the second example is reaction with sulfuric acid. So again we're using, this time we're using sodium. Sodium with the reaction with sulfuric acid, H2SO4. So it will produce metal sulfate. In this case, we are using sodium as the metal and production of sulfate. So here Na2 plus hydrogen gas. So for the reaction, we using 2 mole of sodium reacted with 1 mole of sulfuric acid and production of 1 mole of sodium sulfate and 1 mole of hydrogen gas. The fourth reaction is reaction with alkaline. So for this one, it will react with alkaline salt and it produces oxygen and hydrogen gas. So let's take potassium as example. So let's say we have here potassium and it will react with the same metal alkaline and it will produce metal oxide and production of hydrogen gas. So here we are using 2 mole of potassium reacted with 2 mole of KOH and forming 2 mole of oxide. So another example. So let's say we are using rubidium. So we need rubidium hydroxide. It will form the oxide and production of hydrogen gas. So the fifth example is reaction with halogen. It will react with dry halogen at high temperature and produce halide salt. So we make some example here. Let's say we use lithium and reaction with chlorine gas, it will produce the halide salt. So we will have lithium chloride. So we can use another example of sodium react with bromine gas. So the gas need to be a dry gas and produce sodium bromide. And another example, let's say we use potassium reacted with iodine, we will get potassium iodide. The sixth example of the reaction is reaction with sulfur. So it will react with dry sulfur at high temperature and produce a sulfide salt. So we take several examples here. So again, lithium reacted with sulfur at high temperature and we will get lithium sulfide. So another example. There are a lot of potential application for element in group 1. So the first example of the application is lithium-ion battery. So we can find lithium-ion battery in many applications. For example, for the battery for your handphone. So this is the battery and lithium being utilized for the battery application. So this is the typical layout for lithium-ion battery. So we will have the positive electron and negative electron. Lithium will be used for the production of positive electron. So we will found it as lithium cobaltate. So lithium will be incorporated with another element. So it's also been used for electrical vehicle. So this is a electric car in which it been embedded as a battery on the car, and this picture showing that the car is being charged through the electrical devices. The second application is for breathing apparatus. The breathing apparatus is used for firefighter and miners. So it will produce oxygen gas and remove carbon dioxide during breathing. So for this one, this is an example of the device. So looking to the schematic diagram, here is the part where the, in this case, potassium superoxide used for the application. It will be put as a mat, and here during breathing, water will be produced. So we will exhale water and also carbon dioxide. So in this reaction, the KO2 will reacted with water and produce oxygen. So this oxygen will be used for breathing, and it also produce KOH. So the KOH will be used to neutralize the carbon dioxide that we exhale and produce a carbonate. This is an example on how the assembly of KO2 and this device can be used for the breathing apparatus. So with that, thank you.